Thank you so much for kicking it off today. I'm excited to quickly move on to our next speaker today, which is hailing from San Francisco, from Pinterest. Her name is Jessica Chan. Come up here, you can connect your laptop. She is going to share some war stories with us about how it is possible that so many bigger and older applications today all of a sudden seem to be using React as well. I mean, how's that possible? Well, that's possible thanks to people like Jessica, who has worked on switching Pinterest from Django and Jinja and Nunjucks, I think, to React, and she will share some of her learnings. Give a warm round of applause to Jessica Chan.
Hi, everyone. So good to be here. I'm, like Max, so excited to be in this city. I am from San Francisco. My name is Jessica Chan. I'm a software engineer at Pinterest, and I'm going to be talking about our journey here at Pinterest to switch our template rendering engine over to React from our stack, from our existing stack. I've been at Pinterest for 2.5 years. Again, we're based out of San Francisco, and I've been on the web platform team the whole time. I love it there because at work, there's nothing that brings me more joy than to learn about systems and get to know them and know them like the back of my hand and then make them better, make them faster, or achieve some kind of business goal. So I've been very happy at Pinterest, and I've been recently mired in the world of server-side rendering. So Max gave a great presentation on the front-end side of things, and here I am taking you into the server den at Pinterest. That's my son up there, that's Miles. I'm teaching him React in this picture, obviously. He's probably asking me why Fiber's not ready yet, but smart kid. And I'm on Pinterest at MissyJCat, and you can tweet at me at MissyJCat. Great. So quick agenda, I'm gonna start out with the road to React and how Pinterest started thinking about React and how to get there from where we were. Also, the reasons why React. We were actually considering other libraries at the time. It was 2014. Angular was still on the table, Ember.js, other libraries. And then 3, 4, and 5, I'll be taking you really deep into the details of the actual execution of the plan that we came up with. And then finally, I'll be talking about where we are now and the current status of Pinterest migration. So first, the road to React. In thinking about how we wanted to go about moving from our current stack to React, we discovered that it would be impossible just to make the leap. That seems obvious now, but at the time, we're just like, how do we do this? How do we go from Jinja on the server side, which is our template rendering engine server side, and Nunjucks, which is a port of Jinja on the client, over to React on both, taking advantage of JavaScript isomorphism and a lot of the benefits of React server client hydration and such. We can't just jump. That's not possible. There are a few obstacles that we had to consider, and identifying what these obstacles were really helped shape the roadmap to React. And just as a note, server-side rendering is important to Pinterest. So we did consider, maybe we could just go on the client and just do React on the client. But unfortunately, for SEO purposes and for performance and other reasons that I can talk about in person, that wasn't an option for us. So the two main things that we discovered were blockers to going to React was the fact that React can't be rendered by Python. I'm sure there might be a Python library out there that renders React, or I don't know, but it's probably not very popular. And we also can't halt development. We can't just say, hey, let's stop everything and convert everything to React, and then let's continue. We couldn't do that. So what we had to do was we had to introduce this interim step. And actually, the majority of my presentation is actually going to be talking about the architecture of this interim step that we had to do first in order to even get to React. And that is, on the server side, we had to be able to interpret JavaScript. So Python wouldn't be a blocking factor. And then we also had to make sure that we didn't have to stop everything to get to React. We didn't have to stop and convert everything to React in order to continue. So the interim step here was to have Node interpret the JavaScript on the server side for us, and then also have Nunjux, which is, again, a port of Jinja, be the main template rendering engine on the server side. So I'll be talking a little bit about that. What this does for us is it unblocks server-side rendering when Node is doing the rendering. We have JavaScript on the server side. And we have a Nunjux engine on the server, meaning that our developers don't have to convert all of our templates over to React right away. We can continue working, and we have a nice path to React, but we don't have to actually convert everything to React. So why React? You know, this is a lot of work. Why even do it? Is it really going to be worth it? We did a lot of research, and React really became the winner for the following reasons. We realized that there would be performance gains with the new library. We did some micro benchmarking. We really wanted to take advantage of the huge developer community. I mean, look at this place. This is amazing. This is what we want, right? We want all these people who love this framework, who are building it out, making it better. We wanted to be part of that. There were design patterns in React that were very compatible with our current, our legacy stack, and that really helped us see a path forward. And finally, React has a great developer experience, which I'll be talking about later. The way that we develop here at Pinterest has greatly changed since the adoption of React. And also, there's a lot of other benefits that come with a lot of other libraries that form the ecosystem of React. I mean, these are libraries that we are able to explore because of this, because of this and other projects that were part of this huge migration. And we're very excited because this is what we started with. And this has served us for quite a long time, but in order to move forward, we really had to rebuild what we had here. Django, Backbone, Nunjux, Python. These were serving Pinterest very well for the first few years, or for those years that we were going, but React is really where we wanted to go. Just to give you an idea of scale, Pinterest has 175 million monthly active users. That's more than the number of people that live in Russia, just for scale. And to give an idea of load, we serve 150,000 requests per second. That's our servers. So I like to say that Pinterest is a lot like a very busy and in-demand airline. There are passengers, which I consider like users, boarding and arriving every second. And pilots, which I'm going to say are the developers. They're very busy navigating destinations every day and making sure passengers get from A to B in a very timely manner. These developers are very busy. They have a day job. They have day-to-day. Meanwhile, the assholes in ground control, that's us, that's the web platform team, we're just sitting back, daydreaming and thinking, oh, these planes look nice. These pilots are busy. Business is good. Let's rebuild them all. I heard about this new fancier plane. I think we should upgrade. Let's run it by the developers, or let's run it by the pilots. So we say, hey, pilots, land all your planes for a sec. We want to rebuild all the planes. You can imagine what the pilots are going to say to that. At Pinterest, it's very similar. There's features to put out, goals to hit. All the developers out there, they're very busy doing their day-to-day job. And you can imagine that they are interested in React, but not if that means they have to stop everything and convert. And so, how do we solve this? Have you ever heard the phrase, don't ask for permission, ask for forgiveness? We basically said, fine, pilots, if you don't land and come to us, we'll come to you. We decided to basically rebuild Pinterest while it was flying. Without really needing it to stop at all, basically. In fact, to say that we rebuilt Pinterest while it was flying isn't 100% accurate. I'm going to be going into the architecture of what we actually did, which is we actually just put an engine on top of the old engine while the plane was flying, and we forced the old plane to basically use the new engine so we could drop the old engine. That's really, in a nutshell, what we did. So the point is, for this to work, we needed to make sure business could go on as usual. That's a key business requirement. And you have to remember that we are a single-page application, but we're made up of hundreds of modules in constant development, and we're serving over 150,000 requests per second. So that key requirement is the reason why we need this middle step. We can't just go to React. We can't just stop things. We have to have a way to keep the plane running while we rebuild. So going to one engine. OK, I'm going to get pretty technical now. In order to understand this, I just want to give a little context around the request lifecycle and how our stack works. User makes a request and requests Pinterest.com. The server comes back using the Jinja engine, rendering HTML and sending that as a response back to the browser, which then spawns additional requests and gets more assets from our CDN. It does also come back to the server for data, but not for template rendering. Any additional user events actually get handled by the client, by Nunjux, which is doing the template rendering on the client. Backbone and Nunjux power that client HTML, and we have also some JavaScript logic that are doing data fetches and other things. Now, I'm going to also talk a little bit about our code syntax, what Nunjux looks like. Is anybody familiar with Nunjux at all? Oh, OK. Jinja, yeah, some people. Cool. All right. So this will look familiar to some of you. Here, we're just setting a few variables. Greeting, name, pin data. Data is an object, and we're just getting some fields off the object. And the first two lines, hello and guests, those two values are just default values. So if we don't find the field greeting or name in the data object, it's going to default to that. Not anything you really need to worry about. In Nunjux, those two double brackets mean we're evaluating something. And we're actually spitting out this line as HTML or as part of the response. So if there were no values for the first two variables, it would just say, hello, guest, welcome to Pinterest. Now, this third line is interesting. The module keyword is actually a function call. And what it's doing is it's actually asking Nunjux to find the template called home feed and pass it some options. And what Nunjux will do, the renderer engine will actually find that template and go ahead and output that as the output, as the render output. And so already you see that we have a tree, right? We have a parent template and we have a child template. The home feed is the child of this template, and we're passing it options. Does this pattern seem familiar, right? React works in a similar way, right? Another thing that we had to do at Pinterest is because we had Jinja on the server and Nunjux on the client, it was great that they could both read this and have the same-ish output. Every time a developer wanted to add a new utility or library to our template rendering engine, they had to do it twice. They had to do it once on the client in JavaScript, and they had to do it once on the server in Python. So to be a developer at Pinterest, you had to know Python and JavaScript and be able to debug it. That was not fun, just a side note. So again, here we are going from Jinja and Nunjux, Jinja on the server, Nunjux on the client, over to React. Let's just pretend for just a second that there was a magic wand and I could actually convert all of our Nunjux templates that you just saw over to React, right? Let's just pretend that I could actually magically turn that over to React, all of our templates in at once, some crazy transpiler or something like that. We still have this problem, right? Can we do React on the server in Python? No, what? I don't know. It's not going to work. We need server-side rendering. So we can't just have React on the server. So what we ended up doing is we ended up standing up a side process, a node sidecar. We call it a sidecar process. And what this does is it acts as a glorified RPC. It uses a network interface so that our web server can call this process, and all it's responsible for doing is rendering a template. That's all it does. So what we ended up doing is having our web server still live in Python, still live in Django, but instead of having Jinja in process, rendering a template and spitting out HTML, it's going to go and call this side process over the network interface, and it's going to return HTML, and it's going to do the exact same thing. The other cool thing about this is JavaScript. Yay, all around. We have nunjucks on the server, or whatever, template rendering on the server and on the client in the same language. So if we write utilities in one, it's going to work for the other, mostly. So that, again, is why we need the second step. By having nunjucks on the server and nunjucks on the client, we don't need that magic spell to magically transform all of our templates from nunjucks to React. We can take our time. We can do it at our own pace. And as we do that, we can then finally get to React, which is the end goal. So there. Okay, now, the architecture of going from that in-process Jinja template rendering over to calling this node sidecar process is also pretty interesting. So again, we have this. Remember, what we're doing here is we're building another engine on top of the old engine, and then forcing the plane to use that new engine, and then basically dropping the old engine out of the sky. So this is the architecture of the old engine. Again, we have this user agent making a call to the Django web server. And what this represents, this empty circle, is a latent module request, or I'm going to call it a module request. It's latent because it doesn't have data yet. We actually need to make a fetch for data in the beginning of this cycle in order to know what render path we want to go down. So we're going to go to the API, fetch our data on the server, and then we're going to start rendering out a tree. This is Jinja following all those module calls and rendering out the tree as far as it can with the data it has. One thing to note is that this is CPU blocking. So that means this process can't do anything else while it's doing this. Then, we know that there's a couple templates that actually need more data. We don't have the data yet. Our engine has the logic to know this. So we're going to go ahead and make another call. And our old engine, Jinja, will then take that data and serially render each subtree. And it will continue to do this until all the trees are rendered. Now contrast that with the new system. This is the new engine. As before, we are making a request from the new user agent over to the Django web server. We are again fetching data, just like before, but instead of in-process calling a Jinja library from Python, we're actually going to make a network call over. And what we have here is this Nginx proxy layer. Nginx is great at being a load balancer / proxy layer. And we're standing up several node workers, several node processes behind this Nginx proxy layer as upstreams. And what this means is we can scale that up and down, right? What it also means is that we can actually do this asynchronously. So it's not blocking the Python thread. What it's going to do is that node worker is going to use nunjucks to render the template and return the exact same HTML that the Jinja renderer would have returned. We know that we need more data, so we're going to make another call to the API backend. And what comes back, or what Python is about to do, is about to make two completely independent render requests with these. So Node has come back with a template and holes. It knows that there are these two holes. And what we're able to do is have logic that turns those holes into two completely independent data requests that can then, in parallel, parallelize the CPU blocking work. And this was responsible for a lot of the performance gain that we got from this new architecture. Both trees are then rendered in parallel. And as before, we're going to be fetching data and doing this until the entire tree is rendered. OK, rolling this out. Yeah. we're in flight, right? There's two engines. We got to flip one over to the other. We don't do that all in one giant step, especially not when there's a lot of passengers' lives at stake. This is a cockpit. This is kind of my analogy. I'm taking it forward. Developers are pilots. You know, they're coding. They're doing a lot of things. But there are a few things, there's a bit of a risk because there are some things that they can do in the templates that could cause the template engine to crash. There are some things that we need to lint against, some automated tools that we need to use to make sure that developers do the right thing while we're making this transition. And I'll give you an example of what some of those things could be. But ultimately, what we really want to avoid while we're rolling this out is for a developer to accidentally do something that could cause the plane to crash. That would be disastrous. So, one example of this is some interesting language differences between JavaScript and Python. You can see here in JavaScript, I should have put a var or const up there, but data has a value of empty object. In Python, data has a value of empty object. These actually evaluate to different truthiness, falsiness. So in this template, if a developer were to code something like this, if data, right, we're just trying to figure out truthiness, falsiness there, the template rendering engine in JavaScript will render, woot, we got data, but in Python it won't, right? And that's going to cause some breakage, some discrepancy between the server rendered and the client rendered stuff. And that could cause some bugs. So what we did is we had a render all test. What this meant is when you wanted to commit something during build time, we would run a test that rendered every single template and compare the output. And the developer, while they're developing, would actually see this feedback as they're coding. And what this helped us do is prevent a lot of crazy bugs that would have arisen while we were rolling this out, just from developers simply not knowing a very simple thing like that. With hundreds of developers, this is essential to automate. Another thing we did is I wrote this nunjucks lint extension that basically lints, or it's basically a linter for all nunjucks templates. Is anybody familiar with ESLint? Right? This lint extension actually registers rules that you can write, a developer can write, in ESLint style fashion. And what it does is it's another build time step that takes over the nunjucks parser and applies the registered rules to every abstract syntax tree node. And what it does then is throw an error if there's something that's meeting some condition or not meeting some condition. So here's some of the rules that we wrote. And here are some of the errors that would come up. So for example, JavaScript doesn't support tuple syntax. So if a developer were to write something like set y comma z equals foo comma bar, that just wouldn't work in nunjucks. So this instant feedback really helped us make sure that as we were rolling out, developers weren't doing things that would break the site. Another trade-off that we did make was the sidecar process that we stood up actually comes with a cost. It's a microservice that is on the critical path. So that means if all of our node processes go down, like Pinterest doesn't work. There's nothing rendering the templates. So the thing to remember is if you do adopt this idea, make sure that you know the cost, and that is you need to have on-call rotations. You need to be measuring latency. You need to have debugging tools, a runbook. We have alerting that will alert me in the middle of the night if suddenly all the hosts are running hot because the processes are doing something bad with the code. There's still some mysterious CPU crazinesses that have happened that I'm still tracking down. But there is definitely a cost to standing up microservices, and that's something to be aware of. Also here at Pinterest, we have what's called an experiment dashboard. Here's just an example. And when we roll something out, we roll them out usually in like 5 to 10% increments, and we do A/B testing. And this dashboard lists out all the metrics that we care about and tells us if any of the metrics start going down. So there was an example where, as we were rolling out this project, there were an event that we care about, board edits, were going down. This is a representation of the percentages that it was going down, which pointed to, it wasn't a huge percentage, but it was blocking the rollout. So this didn't mean that, it seemed to mean that there was no huge bug, it was some kind of subtle side case or edge case that was happening. And this means the number of days that we saw the bug resolved. It does say some negative numbers still, but I'm not a data scientist. It's something about statistical significance. But basically, when we see gray, that means we're flat, we're good, we're good to go. We also use OpenTSDB to stat metrics. So when we were tracking down this bug, we were tracking down all kinds of layers in the code path to see exactly where the bug was manifesting. And OpenTSDB is a great tool at Pinterest. We use it all the time for all kinds of stats, for all kinds of debugging and tracking and monitoring. That it's a very indispensable tool. Here we did track down the place in the code that this bug was happening, and here you can see the bug manifesting, and here it was actually when the deploy was fixed. So we could actually see that the bug was resolved, as well as in the experiment dashboard. But this is real time. We also track performance very, very, very closely. The architecture was great. The node sidecar process, we were very proud of it. But the early iterations of that architecture were slower. And I can talk maybe over the coffee break what kinds of optimizations we made. But basically, again, we're using OpenTSDB, and we are tracking in real time the performance of red, which represents the node Nunjux architecture, versus the green. And we were not able to launch this until we were comparable in terms of performance. So that's something that is very valuable to us. So today, 100% of Pinterest.com templates are rendered server-side by Node and Nunjux. And Jinja is completely deprecated as a dependency. Now, on to the future of Pinterest. So before, again, we were rendering Jinja on the server, Nunjux on the client. Now we're doing Nunjux on the server, Nunjux on the client. Oops. How are we getting here? This is in progress. So remember this template that I showed you earlier? This is now being rendered by Nunjux on the server, Nunjux on the client. What we did is the iterative move to React is also an experiment. It's also something that we need to test. We can't guarantee that when we migrate a Nunjux template over to React that everything's going to stay flat. So again, we have to put this in experiment just as we did the template rendering change. But this time, instead of me having to flip everything at once in order to use the new engine, we can actually flip templates at a time or flows at a time. So this is what this looks like. So you see the difference there. Instead of just calling the module keyword in order to render a Nunjux template, we have an if branch, and in React experiment, that's something that's part of our experimentation framework. You don't have to worry too much about it. But if we're in the experiment, we will then use this other keyword component, which is a custom function that will actually render a React tree instead of a Nunjux tree. And you can see here we're passing in props. Well, we could have called that whatever we want, but we wanted to name them consistently with the React conventions. So what this looks like, and if we're not part of the experiment, if we're in the control group, then we're rendering the home feed Nunjux nodule. So what that looks like is, again, we have a React tree, and we are running an experiment. The control group is still rendering the Nunjux side, and the enabled group is running the React side. The experiment dashboard is showing us during this experiment any drops, anything that drops. So if there's a drop, we can't roll out. But if there's no drops and everything's flat, then we can roll that out. And ta-da, we're done with that branch. Conscious decision that we made when coming up with this architecture is we've had cases where developers would come to us and say, hey, Mary is converting this subtree to React, but you know what? I own that node at the bottom, and I'm not ready to convert yet. I'm actually still doing some work. Can we just have the React tree call back to nunjucks. And we had to think about that because, you know, that's a valid case. But we had to say no. Once you go React, we don't go back. So that really helped us. That decision, I think, really helped us move forward more quickly instead of having, you know, a few strides forward and a couple steps back. So given that, what we're able to do then is convert more trees. And since we've already rolled out this subtree to React, we're really just worried about converting these other nodes from nunjucks to React. And so this is the current status. We're currently in the process of migrating all of our template code iteratively to React. It's actually a very big effort that's growing in priority right now. And we've actually done it for some flows already. We had converted the user profile page over to React, and we've seen a 20% gain in performance and engagement. Very, very measurable results that really justify some of the business reasons why we made the change in the first place. We also converted our unauth experience over to React, and we saw a 30% gain in performance, which is great. It's really amazing. Also, the developer experience, the duplicating of Python and JavaScript was really a pain in the butt. So the fact that that was just completely eliminated, really, really big celebration over on the developer side. We also didn't need to onboard new developers on nunjucks. You know, that's just something we just didn't have to do anymore. And we also didn't need to tell them, you know, you need to learn Python now, right? JavaScript will carry you developing at Pinterest now. In React, render logic is consolidated in one place, right? That makes debugging a lot easier. One-way data flow, more manageable. Again, consolidating on one language. And also the developer community. Again, this is amazing to be able to answer questions with Google. And when somebody says, hey, is this documented somewhere? You could just point to the React web page instead of our wiki that grows obsolete all the time. So that's a pain point that we eliminated as well. So great developer experience here. And so going from this to this has been a great journey for us. We were very excited to have done it. And we're exploring all the time the new possibilities and new technologies that everyone's talking about. And we're just very excited to be part of this community now that we've achieved this milestone. And so while there is still a lot of work to do, we're still very much in the thick of migration. With the results that we've seen so far, we're very confident that this architecture, a lot of work, but worth it, will give us some pretty amazing gains all around. Thank you.
Thank you very much, Jessica. We have a little bit of time for a few questions. Anyone who's got a nagging one?
Hi. Out of curiosity, do you have a rough timeline for how long it took each step to take?
Sure. For the nunjucks node migration?
Yeah, exactly.
I started this project in October 2014, and it was 100% in end of July or beginning of August. So the entire migration or that architecture took around 6, 7 months. Also, I was out for holiday, so.
Okay, thank you.
Mm-hmm. Oh, back there.
Hi, I was wondering, you had a kind of situation where you had a subtree, so you had one part React, one part Backbone nunchucks.
Right.
Did you actually take a performance hit, and how big was the performance hit running the hybrid application in production?
Oh, I'm sorry, I couldn't hear the last part.
Did you take a performance hit for running the hybrid in production, like the
Oh,
React?
performance hit.
Yeah, and what kind of numbers?
Sure. Actually, no, not at all. What we did is the mechanism that is rendering out the nunjucks tree is simply overridden with the React render to string on the server side. So actually, like, there was no performance hit. It was simply, they're just function calls, just different branches, but no, there was no additional architecture needed. It was simply render to string.
And on the client side?
On the client side, there was none as well. We simply rendered a React tree, and there was no, it was pretty straightforward actually with the nunjucks ability to define these function calls within the templates. It was pretty straightforward actually.
Okay, thank you.
Any more questions?
Oh, I will say actually, mount component actually did show that there was some slowdown, but it wasn't, there might have been something else that was offsetting it because overall there was no performance hit there. In fact, there was more gain, so the offset was overtaken that. Last question.
Hi. Sorry. I'm just wondering, to scale, I believe you provide a lot of autonomy to teams. And you have a lot of teams, I believe. So how do you ensure you provide really great experience performance-wise? And how do you challenge the performance excellence?
That's a good question. A lot of our measurements in the experiment dashboard, which is something that not just the platform team uses, but all feature teams use, do have performance metrics. So if there is performance regression, then that is made very public. And all experiments that are ever run on Pinterest, from within Pinterest, you can see every experiment that's being run. So it's very much the culture here that if there's a regression, we need to fix it or not launch. Cool. Thank you.
Thank you very much, Jessica. Thank you for showing us all the planes. Thank you for showing us some of the engagement metrics on a scale of Pinterest. That's really interesting. That's really encouraging also for continuing on this path of using React everywhere we can, which is our main purpose in life, right? Wouldn't you agree? All right. Thank you all for showing up.